We're going to work on some review for today. You guys have a quiz tomorrow and Friday. So you guys who are on Zoom at home, I will see you tomorrow for your quiz. And you guys who are in person, I will see you on, I will see you guys on Friday for your quiz. So today we're going to work on some review. And I wanted to start with some of the problems at the bottom of page 139. So if you would for me, please open up to page 139 and take a look at number 5. So your homework last night on page 139 asked you to solve using the elimination method. So what we are looking for with the elimination method is for one of our variables in those equations to have opposite signs. Do I have that already for number 5? No, not yet. No. For my x's, I have 4 and 3. And for my y's, I have -2 and -1. So what I'm going to end up having to do is to multiply one or maybe both of those equations by some number to get those variables, whichever ones I choose, to have opposite signs. So does anybody have an idea on what variable may not be too terrible to eliminate? Y. So if I want to eliminate y, what equation are you going to multiply and what are you going to multiply it? Multiply the bottom equation by -2. -1 times -2 gives me +2 for y, and then I can eliminate the y terms. So I'm going to go ahead and multiply by 2 and write that over here. So that would be -6x plus 2y equals 16. And then the top equation, I'm just going to recopy. So 4x minus 2y equals -14. And then we'll add those together. Just 1 second. Then we'll add these equations together. 4x minus 6x would be -2x. -2y plus 2y is 0, so the y's are gone. And then -14 plus 16 would be 2. So now I only have an equation in terms of x. I can divide both sides by -2 to get x by itself. And we get x to be -1. Once we found x, we can plug that value back in to either of our original equations to find y. I'm going to plug this back into the bottom equation. That seems a little easier to me, but if you'd rather plug into the top, that's fine too. So we have 3 times -1 minus y equals -8. 3 times -1 is -3 minus y equals -8. I'm going to move this 3 to the other side by adding it. Then I have -y equals -5. I want y, not -y. So my next step is going to be to divide both sides by -1. And I get y equals 5. Now that I found both x and y, I can write my solution as an ordered pair. So that would be -1, 5. Any questions on number 5? Okay, so this is elimination. That's what we looked at yesterday. We've also talked about solving systems of equations using graphing and using substitution. So we'll review those methods as well a little bit later. But here we had a sort of a leftover homework problem I wanted to chat about really quick. Okay, if you would for me, please turn the page to page 140. Something else we worked on a lot before we took a break for Thanksgiving was how to be able to write a system from a word problem. So I'm going to practice that here as well. So number 7 on page 140 says you are selling tickets for a high school price. Student tickets cost $4 and general admission tickets cost $6. You sell 525 tickets and collect $2,790. How many of each type of ticket did you sell? So I've got information about the total number of tickets I sold, and I know there were 2 types of tickets. And I also have information about the total amount that I made with prices for each of those 2 types of tickets. So I'm going to use S to represent the number of student tickets that we sold. And I'm going to use G to represent the number of general admission tickets that we sold. If you want to use different variables, you can. If you want to stick with X and Y, that's fine. So I know I sold a total of 525 tickets. So if I take the student tickets I sold and add them to the general admission tickets I sold, I get 525 total tickets. I know how much student tickets cost. It's $4 for every student ticket. And it's $6 for every general admission ticket. So 4 times S gives me how much money I made from student tickets. 6 times G gives me how much money I made from those general admission tickets. If I add up how much I made from student tickets and how much I made from general admission, I would get the total that we collected, $2,790. So there's my system of equations. Now, from here, I want to solve for S and G so that I can answer that question. How many of each type of tickets did you sell? Since this was sort of wrapped up in your elimination homework, I'm going to go ahead and use elimination as my method here. On your quiz, I will have a problem where I ask you specifically to use graphing as your solving strategy. You'll have a problem where I ask you specifically to use substitution and one where I ask you specifically to use elimination. So as we're working today, we're going to practice with each of those methods as a refresher. And I'll give you a couple problems where you can choose whichever method you'd like. But since I am going to ask you specifically to use substitution and to use elimination for a couple different problems, I want to make sure we review each of those. So we'll do this one with elimination as well, and then we'll do a couple with substitution a little bit later. So if I'm going to use elimination on this thing, I'm looking here at which variable would be easier to eliminate, and it's going to be roughly the same amount of work either way. I know I'm going to have to multiply this top equation by either -4 or -6 to get my S or my G to eliminate. So I'm making my decision based on what seems like easier work to me, and I would rather work with a little bit smaller numbers. So I'm going to multiply by -4 rather than -6. I know that's how a lot of us kind of make that decision when we look at problems for elimination. I don't want to have to work with huge numbers, so I'm going to choose not to. So I'm going to multiply this top equation by -4. So down here, I would have -4S minus 4G equals -2,100. Now my S's have opposite coefficients. So I can add my equations together and my S's will eliminate. 6G minus 4G is 2G. And 2790 minus 2100 is 690. Now to get my G by itself, I'm going to divide both sides by 2. And I get G to be 345. Once I have a value for G, I can plug that back into one of my original equations to solve for S. I'm going to plug this into the top equation. So S plus 345 equals 525. Now I'm going to subtract 345 from both sides, and I get S to be 180. Since this problem has a context, I'm not going to give my solution as an ordered pair. I'm going to state what each of these values represent. So we sold 345 general admission tickets. And 180 student tickets. Questions for me on number 7? Okay, so we've done a couple examples of elimination. Let's take a look at some of our other solving strategies. So I'm going to turn the page to 141. And number 1 is asking us to solve by graphing. So I have 2 different equations here. I want to graph each of them, and then our solution will be where, if anywhere, those lines intersect. So I'm going to start by graphing this top equation. Y equals 1/2 x minus 3. My y-intercept here is -3, 1, 2, 3. And then my slope is 1/2. So that means I'm going to go up 1, forward 2. Up 1, forward 2. And then to get some points back this way, I can reverse those directions. Down 1, back 2, down 1, back 2. For that first line, I want to make sure I cover as much of my coordinate plane as I can. I don't know where that other line is going to land just yet. So I want to make sure that I really, with that first line, go all the way across my coordinate plane so that wherever that other line intersects, my first line's already there. And then for my second equation, y equals -x plus 3. So my y-intercept this time is +3. And this negative in front of x would be -1. That's my slope. So I'm going to go down 1, forward 1, down 1, forward 1. Thank you. And then sketching our line. My solution here is the place where those lines intersect. So that would be the point 1, 2, 3, 4, comma, -1. Questions on number 1? Okay. So if we hop down to this next section, it says use substitution. I told you guys I'm going to ask you to use each of our different methods on the quiz. So I want to do some practice with substitution as well. The nice thing about number 3 is that in my second equation, I already have a variable by itself. Remember, for substitution, one of those equations has to have a variable by itself. So in that second equation, we already have x by itself. That means I can take this stuff and plug it in for x in my top equation. So this would be 3 times 2y minus 1 minus 5y equals -4. Now I'm going to distribute that 3 inside parentheses, and I get 6y minus 3 minus 5y equals -4. Now on the left, I've got some like terms to combine. 6y minus 5y would just be 1y minus 3 equals -4. And then to get y by itself, I'm going to add 3 to both sides. So I get y equals -1. Then just like with our elimination method, once I have a value for one of my variables, I go back to my original equations and plug it into one of them. I'm going to plug into the second equation here. And we get x equals 2 times -1 minus 1. Now when I go to simplify, 2 times -1 is -2. -2 minus 1 gives me -3. Once I have my value for x and my value for y, I can write my solution as an ordered pair, -3, comma, -1. Any questions for number 3? Number 5 is asking me to use elimination again. So if I take a look at number 5, my values, my coefficients, I should say, for x are 3 and 6. For y, I've got 2 and 4. So I don't have opposite coefficients yet. So what can I do to get those opposite coefficients? Multiply which one by -2? Yeah, multiply this top equation by -2. And I'll just rewrite that down here. So that would be -6x minus 4y equals -8. Now I can add my equations together. 6x minus 6x means my x's are gone. And then 4y minus 4y means my y's are also gone. So what do I have on this side of the equation? Nothing, right? The x's are gone, the y's are gone, 0. And then on the other side, 10 minus 8 would give me 2. So I've got no more variables. And this equation that I'm left with is incorrect. 0 is not equal to 2. What does that mean for my solutions here? Very good, no solutions. Questions on number 5? We took a look at a similar example, I think that was yesterday with substitution, where we ended up with something like this and it was no solutions. Just a couple more I want to take a look at with you guys. So on the next page, page 142, for 7 and 8, I get to choose the strategy that I would like to use, okay? So again, on your quiz, I'm going to ask you to solve one by graphing. I'm going to ask you to solve a system by substitution. I'm going to ask you to solve a system with elimination, and then I'm going to give you a couple where you get to choose, right? You get to pick whichever method you think works best. So if we take a look at number 7, as I look at this, I'm thinking, well, that's just a plain old x. It'd be pretty easy to move that y term to the other side, and then I could use substitution. Anybody else looking at that thinking substitution is a good option there? A couple of us. Is anybody looking at this thinking, well, if I just multiplied the top by -9, I could use elimination? Not big fans of elimination, that's okay. Yeah, I would probably use substitution for this one as well. You could just as easily use elimination. You have to multiply the top equation probably by -9. If you wanted to eliminate the y's, you'd have to multiply both equations. But for the same reason that I eliminated, back on this page, I eliminated the s's because I could multiply by a smaller number. That's the same reason I would probably not choose elimination here. Multiplying every term in here by 9 means my numbers are going to get pretty big. Okay, so I'm going to go ahead and get x by itself here. That means add 7y to both sides. So x equals 7y minus 28. And now I want you to go ahead and solve this one. If you want to use substitution, use substitution. If you prefer to use elimination, you can go ahead and use that strategy. When you finish, go ahead and check your work on this one. I went through this with substitution, but if you used elimination instead, you'll get the same solution. So I took this stuff that x is equal to and plugged it in for x in that second equation. Then I distributed that 9 inside parentheses. Then on the left, I combined my like terms. Then I moved that 252 to the other side. Then I got y by itself by dividing both sides by 65. So I found y to be equal to 4. Now that I have a value for y, I can plug that in to either of my original equations or my sort of rewritten top equation. I chose to plug it into my rewritten top equation and solve for x. So I got x to be 0. That means my solution is 0, 4. And the method I used here was substitution. Questions for me on number 7? Okay, I want to take a look at one more problem together. So if we scoot down the page here and take a look at number 9, we've got another word problem here where we're going to write our own system of equations. The college bookstore sold 40 notebooks and 20 newspapers for a total of $100. A day later, the bookstore sold 8 notebooks and 30 newspapers for a total of $72. How much does a notebook cost and how much does a newspaper cost? So same idea as that ticket problem that we did a few minutes ago. The big difference here in setup is that this time I know how many of each of these things I sold. What I don't know is the price. So I'm going to let B be the price of a notebook. If you want to use X and Y instead, that's fine. And then I'm going to let P be the price of a newspaper. And so I have information on how many of each of these things they sold and how much they made for 2 different days. So for day 1, I know that they sold 40 notebooks and 20 newspapers. So 40B plus 20P would give me $100. And then the next day, I'm going to call that day 2. They sold 8 notebooks, so 8B plus 30 newspapers, so 30P equals 72. So there's my system of equations for number 9. This isn't set up really obviously to use elimination or substitution. You can use whichever you want. So we have it set up together. From here, I want you to go ahead and finish up number 9 and then go back and work through the problems that we skipped. So I believe that would be all the evens. So from page 139, where we started today, we started with number 5 on page 139. You have number 6 left on that page. You should have done 1 through 4 for homework. You have number 8 on page 140. And then you have the even problems on 141 and 142. That's what I want you to work on for the rest of class today.